Hello student, so this is lecture number 2 on amine. So last class we have already completed IUPAC and common naming. So today we'll do some numericals based on that. Okay, so let's do question number 3. These are all MTG questions. Question number 3, they're saying that write the IUPAC name of the following compound. So first I have to draw the structure. So if the structure that is given here is this one, NCH3, right? Now if I expand the structure, I think I will get CH3, CH2, and since there are two, you can clearly see that there is 2 number, so that means another CH2 CH3 is there. Now since I have got the structure, so I have to, there are 3 alkyls, right? So I have to select the alkyl that has longest carbon chain. So there are 2 options, either this one or this one. So now since in both the case the number of carbons are same, so you can choose any one. So I'll be choosing this one, okay, and I will ignore this. So if I ignore this, so this one will behave as side chain and this one will also behave as side chain, right? Now let's start naming it. So since they are side chain, so this one will be ethyl and this one will be methyl. So alphabetically ethyl comes first, but this ethyl is connected to nitrogen. So I will write N-ethyl, then you have dash N-methyl, right? Now let's continue with the main part. This is the parent chain, right? I have to start numbering, so 1 and 2, right? So only 2 carbons are there, so it will be eth, N, amine. Okay, so that's the answer of question number 3. Now let's do question number 4. Question number 4, they have given the structure like name, we have to draw the structure. So what is the meaning of 2,4-dinitrochlorobenzene? Now this name, chlorobenzene is basically Cl and then benzene ring, right? If you are using this name chlorobenzene, so with respect to chlorine at 2 and 4 position there is nitro. Now if I talk about nitro compound, I can say it's NO2, right? So now if I start counting, so it will be 1, 2, 3 and 4, right? So these are the positions. So basically here the nitro compound will be here at the second position NO2 and at 4th position NO2. Actually this question is not from this chapter, okay, it's from haloalkane chapter. So that's the answer. Now let's try the last question, question number 5. Question number 5, write the IUPAC name of this compound. So here CH3, NH, and then given CH and CH3 2 times. That means this CH3 is connected to CH, like 2 CH3s. So if I expand the structure, so the structure will be something like this: CH, then CH3, then another CH3 is there, so it will be like this. Now if I select the longest parent chain, so it will be this one because it is continuous, okay, right? So numbering will be 1, 2 and 3, and this is my side chain, right? So what will be the name of this one? The name of this compound is N-methyl, right? Because this is the side chain. Now we have to write the parent chain. So this one is 3 carbon means prop, then N, and at second position we have the amine group. If you look carefully here, this is at second position, right? So it will be 2 amine. So that will be the name of this compound, N-methyl propane 2 amine. I hope it's clear. Let's try another question. So this question, question number 7, how we will do this? So basically they have given this structure NH2 and then they have given benzene ring, Br, Br and Br, right? Then you have to number it. So I know that this shape without benzene ring, like without the side chain, is called aniline. And if I use this name, then I have to start numbering from here: 1, 2, 3, 4, 5 and 6, right? So if I use this concept, I'll write 1 2 3 4 5 6, right? So at which position we have the side chain? I can say at second position you have side chain, at fourth position you have side chain, and at sixth position you have this bromine side chain. Now since bromine is repeating 3 times, I'll be writing tri, and bromine is, in IUPAC we write bromo, yes or no? And then lastly we will write 2,4,6 tribromo NLE. So with this, how many questions are given in your MTG related to IUPAC naming and common naming is done. Okay, so now let's continue with the next part, that is preparation. Okay, alright, so this is amine lecture 2. So today we'll be doing preparation of amine. So under this, first one is from nitro compound. So what is nitro compound? Let me explain that. Nitro compound is RNO2. So if in any compound you are getting this NO2 sign, this is a nitro compound. If I give some examples, so it will be CH3, CH2 and NO2, right? Then this is also nitro compound. If I give it in terms of benzene ring, so the most important part is NO2 should be directly connected to R part. Okay, R can be benzene ring, R can be normal carbon and hydrogen straight chain, so it doesn't matter. Now here what will be the reagents? Reagent will be either hydrogen will be used, and then nickel, platinum, palladium and ruthenium. Okay, these are catalyst, Ru. This is catalyst. Okay, and here any one will be used. Anyone is not that all the 4 letters you have to write, 4 symbols, 4 elements you have to write. Then in its place they can also use Sn plus HCl. This is second catalyst, and then third catalyst that they can use is Fe plus HCl. Okay, now here what will happen? Generally this RNO2 that is given here, it will just be replaced, this NO2 will be replaced by NH2. Okay, this NO2 will be replaced by NH2. So you have to make sure, you have to be careful with the bonding side. Okay, and one important point here is that it always produces primary amine, primary or 1 degree amine. As you can see that every time NO2 will be removed and in its place NH2 is there. So if on nitrogen 2 hydrogens are there, then it is primary amine. Okay, okay. So now let's do some examples so that this concept becomes clear to you. So first question, suppose I am giving CH3, CH and CH3, and then NO2 is there. Let me use Fe and HCl. So what you have to do, what is my bonding side here? My bonding side is this one or not? So on this carbon, this spot, you have to write NH2. So it will be CH3, then CH and then CH3, right? And here you have to write NH2. That's it. If I give another question, CH3, CH, CH3, C, CH3, CH3 and NO2. So it does not matter what is the structure. All you have to do, you have to focus on the bonding side. Okay, let's use another catalyst here. So here I can write Sn plus HCl, yes or no? So here the bonding side is what? Bonding side is this carbon, right? So all I have to do, I will draw the exact same structure, and on the carbon where NO2 is bonded, I will replace it with NH3, NH2, not NH3. Okay, clear? So that's how we do the first reaction. Now one homework question for all of you, they ask it for 1 mark, like why Fe plus HCl is preferred most in this reaction. Like there is one advantage of using this Fe and HCl, okay, in this reaction. So that will be the answer, is given in your all-in-one book, so you have to study that. It's a one-liner question, it's for 1 mark. Okay, now let's move on to the next reaction. Next preparation reaction is from nitrile. So what is nitrile? Nitrile is anything that has RCN, okay, or it can also be written as RC triple bond N. Suppose if I give some example, CH3, CH2, and then CN, then this one is also nitrile, right? These are some of the examples of nitrile compound. Now here also there can be 3 types of reagent, like any one they can give. First of all, simple H2 and then nickel, platinum, palladium and ruthenium, okay, just like previous case Ru. So they can give any one of the catalyst, alright, or in its place they can give you just LiAlH4, lithium aluminum hydride, or they can give NaHg, is a sodium amalgam. You don't have to research that part, sodium amalgam or something like that. They will not be asking any question from here. And then it will be CH3 CH2OH, which is also called what? What is the name of this one? This is ethanol. Okay, now here what you have to do, so let's say I am giving RCN, you have to remove this CN and in its place you have to make CH2 and NH2. You have to remove this CN and that CN you will change it to CH2 and NH2. That's the only thing that you have to do, okay, in this reaction. Let's do some example so that it will be clear to you. Chalo. Suppose I am giving this question CH3 CH2 and then C triple bond N. It does not matter whether it is CN or C triple bond N, and any one of the reagent is mentioned. So what you have to do, you have to write CH3 CH2. Now this is my CN part, this CN part it will change to what? CH2 and NH2. That's it. Okay, let's do another example. Suppose I'm giving CN and then let's say this is the one, so it will change to CH2 and NH2 and this will be the benzene. Okay, then another question, if I give, suppose CH3 is given, CH and CH3 is there, then CN is mentioned, let's say any one of the reagent is there, so CH3, CH and CH3 will be there, and then this CN will change to CH2 and NH2. Okay, so all you have to do, this CN you have to change every time to CH2 and NH2. Okay, now if you pay attention to this question, like let's take any one example. Let's take a very simple example. Suppose I'm giving CH3CN, right? If it undergoes reaction, so it changes to CH3 CH2 and NH2, right? Now if this is reactant side, you have to remember this, some theory based question comes from there, like it helps you to identify that whether this is this reaction or the other reaction. So in the reactant, what is the total number of carbon? Total number of carbon is what? It's 2, right? Because this one and this one is there. And in product also total carbon is 2, this one and this one. Now if I ask you, what is total carbon in alkyl? When I'm saying alkyl, I'm mainly focusing on this one. Okay, So now here the total number of carbon in alkyl is 1, and here total carbon in alkyl is 2. So here if you observe in this reaction, the total carbon in overall molecule remains same, but the total carbon in alkyl, it increases by 1. Okay, so you have to remember that. Like how it is used, I will explain it during the question part. Okay, just for the timing you remember this. Next one is the third reaction is from amide. Now if you talk about amide, what is amide? What is amide? I can say amide is RCONH2, or it can be RC double bond O NH2. This CONH2 is a functional group. Okay, this CONH2 is a functional group of amide. Okay, so if I give some example, it will be CH3 CH2 then CONH2. I can write like this. Another example can be CH3 CH CH3. I can also expand the amide structure in this way. Okay, these are some of the examples of amide. Now what are the reagents used here? Reagent, here 3 reagents are used, and all of them has to be you have to include all 3. So first one is LiAlH4. okay, and then ether will be there, and then water will be there. It's not or, okay, this 3 reagents, it has to be present. Now what will happen here? So let's say I'm giving RCONH2. okay, then what will happen here? So basically this oxygen that you are seeing, this CO, this oxygen, it will be removed, and in its place 2 hydrogen is placed. That's it. Means 1 oxygen is removed and 2 hydrogen is added. So if I do some example, suppose CH3 CH2 CONH2. So what you have to do, you should just focus on the CO part. All the structure, everything, it will be same. Only the CO part, it will change to CH2 and then NH2 part. Okay, let's do another example. Suppose I am giving CH3 CH3 C double bond O NH2. You don't have to look elsewhere, just focus on this C double bond O part. Everything will be same, and then this CO part, it will change to CH2 and NH2. Okay, if I give this question to you, CONH2. Now any one of that reagent, all the 3 reagents are given. So this one CO will change to CH2 and then NH2. Okay, now here let's do one quick recap of one reaction that we did in carboxylic acid chapter. This is widely used in this chapter, this reaction, carboxylic acid chemical reaction. There was one chemical reaction where RCOOH is there, okay, and it reacts with NH3 and heat. So that COH, basically the COOH, it changes to CONH2. Okay, so you have to remember this. They use this reaction lots of time. So let's do some example based on that. Suppose I'm giving CH3 CH2 COOH, and let's say they use this reagent NH3 and heat. Okay, so here that CH3 CH2 will be there, and the COOH, it will change to CONH2. Of course, this one product you can also rewrite it like this, like CH3 CH2 then C double bond O and H2. Both the products are same. Now why I'm explaining you this one? Let's do one question. Okay, the question is convert benzoic acid to ethyl benzene. In place of this compound they can give any other compound, but the process will be same. What is benzoic acid? COOH, right? This is benzoic acid, right? And ethyl benzene is what? CH2 CH3, right? I'm sorry, it's not ethyl benzene. This one will be, let's say, benzyl amine. It's a memorization name, so you have to memorize. So it's CH2 NH2 and then benzene ring. Okay, this is benzyl amine. Sir, how do you know that this is benzyl amine? I have already explained you. Benzyl is what? CH2 benzene ring, right? And then NH2 is there. Yes or no? Amine, from amine you are getting NH2, and then for benzyl, because this structure is benzyl, right? What is benzyl? CH2 and then this one. Yes or no? This is benzyl. Now here, how to do this? Like, you have to apply this both the reactions. Okay, so this COOH, it will first change to what? By reacting with NH3 and heat, it will change to amide, CONH2. Okay, and then it will react with this reagent LiAlH4, ether and water. Okay, now this CO will change to CH2 and NH2. Not only in this reaction, in the next reaction also they use this conversion, like carboxylic acid getting converted into amide. I hope it's clear. Okay, now let's move on to the next reaction. This is the fourth reaction. This is also from amide. Okay, and the name of this reaction is Hoffman bromo amide reaction. Now here, what's the difference? Let's say I'm giving one reagent. Here reagent will be Br2 or Cl2. So either Br2 will be used or Cl2 will be used, and along with that KOH or NaOH will be used. Okay, so there can be four combinations. The first combination can be Br2 KOH, right? Second combination can be Br2 NaOH. Third combination can be what? Cl2 KOH, and fourth combination will be Cl2 NaOH, right? These are the four combinations possible. Now here, what will happen? Suppose I am giving you this amide RCONH2 and it's reacting with any one of the four possible options of reagent. This CO part, this CO, it will be completely removed. Okay, so your answer will be RNH2. Okay, that's the difference between this reaction and the previous reaction. Let's do some example based on that. So question is, suppose I'm giving CH3 CH2 then CONH2, right? So this CO, if you remove it, then this hydrogen and this nitrogen you just make bond. Okay, so it will be CH3 CH2 and then NH2. Okay, if I give another example, suppose I am giving CH3 CH2 CH CH3 then C double bond ONH2, right? Now here, let's say it's reacting with any one of the reagent, so this CO it will be completely removed and this one and this nitrogen will be bonded together, so the remaining alkyl part it will be same, and here it will be NH2. Okay, now let's compare this reaction with the previous one. Why it's important, I will tell you. So in one side I am writing that the previous reaction that is only from amide, and here I am writing Hofmann reaction, Hofmann homoamide reaction. Now if you pay attention here, so let's say I'm taking very simple example, suppose CH3 CONH2, and it will change to CH3 CH2 and NH2. Okay, now if I analyze this part in the reactant side, what's the total carbon? Total carbon is 2, and total carbon in alkyl is how much? It's 1. When I'm saying alkyl, I'm just focusing on this part. Okay, now here, what about here? This one is total carbon is 2, but total carbon in alkyl is 2. That means one alkyl has increased. Okay, now let's focus on Hofmann bromidamide reaction. So I am taking the same reaction CONH2. In Hofmann bromidamide, what will happen? It will change to CH3 and H2, right? So what's the total carbon? Total carbon is 2, and here total carbon is only 1. And what's the total carbon in alkyl? It is 1, right? And total carbon in alkyl, it's 1. So if you notice carefully here, the total number of carbon in product side is always 1 less than the total number of carbon in reactant side for Hofmann bromidamide reaction. Okay, that's the most important note point. So always remember, this is the note point I am giving. In Hofmann reaction, in Hofmann bromidamide reaction, the total carbon in product is always 1 less than total carbon in reactant. Keep that in your mind. Okay, this statement they use. Okay, is that clear or not? I hope it's clear, right? So now let's move on to the next reaction. This is called Gabriel thalamide synthesis. Okay, this reaction, there is no modification, you have to memorize it. So Gabriel thalamide reaction. Okay, so in Gabriel thalamide reaction, first you have to remember one structure, and the structure is thalamide. In thalamide, the structure is something like this: benzene ring, then C double bond O, C double bond O, N and H. Okay, this one you have to remember. This is thalamide. We did this in in carboxylic acid chapter. Okay, in reaction of amine part. If you refer carboxylic acid chapter, reaction with amine, then you will get this structure. Now what will happen here? Here 3 reagents will be used. Okay, so let's do that. Let's do the reagent part. The first reagent, it will be alcoholic KOH. Okay, so in place of alcoholic KOH, they can also use KOH plus ethanol, or they can also give the formula KOH plus CH3 CH2H, anyone they can give. Okay, then along with that they will give you one alkyl halide, okay, RX, and then they will give you aqueous NaOH or aqueous KOH. Either they will give aqueous NaOH or they will give aqueous KOH. Okay, so here 3 reagents are used. Now all you have to do, suppose I'm giving one reaction, let's say phthalimide is reacting. Okay, it's reacting with alkyl halide, and this alcoholic KOH is fixed, and let's say they have given NaOH aqueous. So what you have to do, you have to just focus on this R part, okay, take the R and then just write NH2. That's it. Like, this is a direct step. I'll show you the complete step also, but this is the direct step. Okay, how you can directly get the answer. Now if I give one example, let's say this phthalimide is reacting with, direct process you don't have to do as long as they are not asking, and it's reacting with CH3, CH3, and let's say Br. You know, right, what is Rx? That's just a note point for those who forgot what is Rx. Rx is alkyl halide. Okay, Rx is alkyl halide. Here R is what? X is basically halogen. That is, it can be fluorine, it can be chlorine, it can be bromine, it can be iodine. If I give some example, CH3 CH2 Cl, or it can be CH3 CH2 Br, etc. This R part is not fixed, it can change. So now what will happen in this case? What is the bonding side? This is the bonding side or not? So this one, it will change, like everything will stay same, only the R part is important, and here it will give you NH2. Okay, if I give you another example, suppose this phthalimide is again reacting. Acha, here I forgot to give alcoholic KOH and then NaOH aqueous. Okay, so let's say this phthalimide again, it is reacting with this one, CH3 Cl, and then alcoholic KOH is given, and this time they can give, I'm giving here KOH and aqueous. Okay, so what will happen here? You have to focus on this one, so it will be CH3 CH3, and then here you have to write NH2. Okay, that's the only thing. Now let's focus on the complete step. Complete step is mainly for observation, you don't have to do it. Most of the time this question on Gabriel phthalimide, it comes for 1 mark, so you can do it directly also. Now if I show you the full step, so full step is something like this. So it first reacts with alcoholic KOH, right? Then this H part will be removed. Which H part? Pay attention. So here it used to be H, right? But now it will be potassium. Then it will react with Rx, and this potassium will be replaced by the R part. Okay, and then lastly it will react with this NaOH or KOH aqueous. Okay, it can be NaOH aqueous or KOH aqueous, and then it will give you RNH2. Is that clear? Of course one side product is also there. If, like, just for observation, it will be C11ONA and then C11ONA, but it's not that important. The most important part is this one. Okay, that's the complete step, but I will again suggest you, if the question is for 1 mark, then no need to show that. Okay, let's do one question based on this full complete step. Okay, because there will be variation only in this part. So let's do one question. Suppose I'm giving you this phthalimide. So first step is fixed, and it will give you fixed answer. So if it reacts with alcoholic KOH, right, then so it will change to K. Now let's say here I am giving the alkyl halide, say CH3 CH CH3 and Br. So this is my bonding site, right? Be careful with the bonding site. It will be bonded to nitrogen. So if you reverse the structure, like if you reverse this structure, so it will become something like this, right? The R part, yes or no? So it will be CH, then CH3 and CH3. Now here you can use KOH aqueous, right? Just take the R part, so CH3 CH and then CH3, and here it will be NH2, means this same R part. Okay, with respect to the bonding side it will come here, and then the bonding side is CH. On that CH you will add NH2. Okay, but again I am saying this complete step don't do it. Okay, just give me 1 minute. Okay, this Gabriel thalamide synthesis, but two note point that they mainly use to ask question related to this topic. Okay, that note point is, first note point is, this reaction is mainly used to prepare primary amines. Okay, only 1 degree amine. Okay, only 1 degree. Second is, it cannot produce aromatic amine. Now when I'm talking about aromatic amine, I'm talking about this one. Okay, because aromatic halide, there is this X and benzene ring. Does not undergo this reaction due to partial double bond character, because of resonance. Okay, now what is the meaning of this? You already know that if any aryl halide is there, it can be Cl, it can be something. We cannot break this bond, right? We cannot break this bond because this bond has what? Partial double bond character. So since it has partial double bond character, it will never give you NH2 because we cannot break this, so not possible. Now let me give one example based on this. Suppose let's say that this is Gabriel thalamide synthesis. Like here I will be doing the direct one, okay. Let's say it's reacting with this one where halogen is directly connected to benzene ring, and then everything is given alcoholic KOH and NaOH aqueous, right? But then also here you will not get any product, no reaction, because this one it has partial double bond character. This one it has partial double bond character, okay. So that's why you will not get any answer. I hope it's clear, right? Now the last chemical reaction that we will be doing today is ammonolysis. This is the last one. Now in ammonolysis what will happen, ammonia will be there, okay, and it will react with alkyl halide, and this alkyl halide it will be excess amount. So what will be the product here? So it's a multiple step process, okay. So let me give you NH3 and then Rx is taken in excess amount. So what it will do, one of the hydrogen from NH3 will be removed, so it will stay NH2 or not, then it will make bond with the R part. Then again, since you are taking this one in excess amount, so again the same reagent it will react with this product. Now what will happen, another hydrogen from this NH2 it will be removed. Now it will stay NH or not, so one bond, one R from the previous case and one R from the new case, okay, from this new Rx, and then again it will react with another Rx, and then here you will get R, 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 and then this R, okay. Then it will again continue reacting with another Rx, and it will give you a very unique product. There is this one, it will make 4 bond, and on nitrogen there will be positive sign, okay, and outside there will be negative sign. You have to write like this. Okay. So this one is called quaternary ammonium salt. Quaternary ammonium salt. Now if you pay attention here, this is 1 degree, okay, this one is 2 degree, this one is 3 degree, right? Clear? Let's do it with one example, okay. Now before that, just tell me one thing, this 2 degree RNH and R, I can also rewrite it as R2NH, yes, and this 3 degree R and R and R, I can rewrite it as R3N, yes or no? Then lastly, this quaternary ammonium salt that you have written with positive sign and X outside, right? This one I can write it as R4N positive and X minus, okay. Now let's do this in what to say, with one example. Suppose I'm giving this one, this NH3 is reacting with let's say CH3CH2Br. Sometimes they mention excess, sometimes they don't mention excess. Then how to identify? Whenever alkyl halide, that R and X, this one, it reacts with ammonia, that means you consider it is ammonolysis and it's taken in excess amount, okay. Now how to solve this? Suppose NH3 is there and is reacting with CH3CH2Br, right? And here this R part along with respect to this bonding site. So bonding site here is CH2, right? So it will react with NH2, that's your first product. Then again it will react with this same alkyl CH3 CH2Br. Now instead of writing the expanded structure, I will write the condensed structure. Okay, it will be CH3 CH2 twice NH, means one hydrogen is removed. Then again it will react CH3 CH2 Br, right? Then another hydrogen from nitrogen will be removed. Now it will be CH3 CH2 3 times N, right? Then again it will react, it will continue, okay, as long as the quaternary ammonium salt is formed. So it will be CH3 CH2 4 nitrogen plus, give a third bracket, and outside you write the halogen. What is halogen here? Br or not? So Br will be here minus. Okay. Let's do another question based on this. This time we'll try to draw the expanded structure. Okay. Suppose I'm giving NH3 again, and this one is reacting with CH3 CH3Cl. Okay. Now what will be the answer? So it will be CH3 CH3 NH2. We'll be doing the expanded one. Okay, here we will not give bracket, so it will again react with CH3 CH and CH3Cl. So one hydrogen from this nitrogen will be removed and another alkyl will be added. So CH3 CH CH3 NH, and reverse the structure. This will be the bonding side, right? If you reverse the structure, so it will be something like this: CH CH3 and CH3, right? Then again it will continue to react with the same alkyl CH3 CH and CH3 Cl. Another hydrogen is removed, and this time the answer will be CH3 CH CH3 N, and then CH CH3 and CH3. This one, this NH, because this hydrogen, this carbon is the bonding site, right? So then I can write the CH3 and CH3 here. Then again it will react with this CH3 CHN CH3 Cl, right? And my answer for this one will be what? CH3 CH CH3, then N CH CH3 and CH3, then here it will be CH CH3 CH3, and here it will be CH CH3 and CH3. There will be one positive sign on nitrogen, right? One third bracket, and outside the halogen, so Cl minus. Okay, I think it's clear, right? This ammonolysis. So whenever any alkyl halide reacts with NH3, you have to do all the 4 steps. Okay. Now there is one important point based on this reaction. It's ammonolysis produces mixture of 1 degree, 2 degree, 3 degree amine and quaternary ammonium salt. Together. So basically, since it's producing a mixture of 1 degree, 2 degree, 3 degree quaternary ammonium salt, so it is a disadvantage. It is a disadvantage of this. The disadvantage of this reaction, and that's why this reaction is not preferred. This reaction is not preferred. If there is no other option, then of course they will use it, but in general they don't prefer this reaction because it does not produce pure 1 degree, 2 degree or 3 degree amine, but rather it produces a mixture of this amines. Okay, So with this we're done with the preparation part. So in our next class we'll be doing numerical question based on that. Okay, so that's all for today's class. Thank you, sir.